Good morning, students. Today we will start the new chapter, that is magnetic effect of current. Previously, we deal with the electric current. Now, our today's topic is magnet and magnetic effect of current. So, in this chapter, we have to know about the magnet, magnetic field, magnetic field lines, magnetic field due to a current carrying conductor, right hand thumb rule, magnetic field due to current through a circular loop, and magnetic field due to a solenoid. These are the various topics that we have to deal now. Firstly, we know what is magnet. Magnet is an object, or you can say the substance which can attract small pieces of iron, nickel, cobalt, etc., and always indicates north and south direction when suspended freely is called a magnet. So, magnet is that substance which always attracts small pieces of iron, nickel, cobalt, etc., and always indicates north and south direction when suspended freely. That is a magnet. Now, magnet is classified in two groups. Magnet is classified in two groups. Say, magnet is classified in two groups. One is natural magnet and another is artificial magnet. First one is natural magnet and second one artificial magnet. Now we have to deal one by one. First, natural magnet. Natural magnet is the naturally occurring magnet. Natural magnet is the naturally occurring magnet. It comes in the form of iron oxide Fe3O4, and in the ancient period this natural magnet is termed as lodestone. In ancient period the name of the magnet was given as lodestone. The meaning of lodestone is wayfinder or pathfinder. So meaning of lodestone is pathfinder. In the ancient period, sailors used to keep this iron oxide with them, and in the deep sea this iron oxide showed the direction in which they had to move. Since this iron oxide is used to find the direction, and that's why the name obtained pathfinder or lodestone. Now, artificial magnet is classified in several groups. Before discussing this thing, we have to know about the artificial magnet. Artificial magnet is the man-made magnet. Artificial magnet is man-made magnet. Means this magnet is developed by ourselves. Artificial magnet is developed by ourselves, and this artificial magnet comes in different shapes. like bar magnet, horseshoe magnet, and electromagnet. These are the various types of artificial magnet: bar magnet, horseshoe magnet, and electromagnet. The bar magnet will be like this shape. This magnet is called bar magnet. Horseshoe magnet has different shape. It is like this, and this type of magnet is considered as a horseshoe magnet. And electromagnet is like this. Suppose it is a piece of iron and a long copper wire is insulated over them, wound over them, and this one is connected to a battery, and this arrangement is called electromagnet. So these are the different types of artificial magnet: bar magnet, horseshoe magnet, and electromagnet. Now we deal with the uses and property of magnet. Uses of magnet. Magnet is used in refrigerator. Magnet is used in radio and stereo speakers, in audio visual cassettes, players, and children's toy. These are the various uses of magnet. So magnet is used in refrigerator, magnet is used in radio and stereo speakers, magnet is used in audio and video cassette players, magnet is used in children's toy. Apart from this magnet is used on hard disks and floppies of computers also. Now, the properties of magnet. First one is directive property. A freely suspended magnet always indicates north and south direction, and this property is considered as directive property because this property is utilized to show the direction, and that's why the name of the property is directive property. So what is directive property? A freely suspended magnet always indicates north and south direction, and this property is called directive property. Now, they always attract the magnetic substances like iron, nickel, cobalt, etc. Second one, magnet has always two poles, north and south. Monopole magnet is not possible. Suppose you are given a piece of magnet, obviously it has two poles, north and south. And suppose you break the magnet in two pieces, then what has happened? Two portions are obtained, and you see these two portions containing separate north and south pole. So obviously these two pieces are acting like the magnet. So you can say This is a monopole magnet, but actually it is not like so. The portion where the North Pole is there, automatically South Pole is developed at the other end, and the piece containing the South Pole develops North Pole in its opposite automatically. So again, these two breaked piece of magnet having two poles, north and south. So magnet always has two poles, north and south. Monopole magnet is not possible. The pole of the magnet which points towards north direction is called north pole, or you can say the north seeking pole, and the pole which indicates the south direction is called south pole or south seeking pole. Now, like poles of magnet repel each other and opposite poles attract each other. Suppose you bring north pole of one magnet near the north pole of another magnet. You will see these two poles repel each other. If you bring two south poles closer to each other, then also you see they repel each other. But if you bring north pole of one magnet near the south pole of another magnet, you will see the attraction between them. That means like poles repel each other and opposite pole attract each other. This is another property of magnet. Like poles repel each other and opposite pole attract each other. Now, magnetic strength is maximum at poles and minimum at middle. Suppose you take a bar magnet and place it near some pins, you will see at the polar region number of pins suspended is more as compared to number of pins attracted at the end. You see at the polar region number of pins attracted is more and least number of pin which is attracted towards the middle portion. That indicates that magnetic strength is maximum at poles and minimum at middle. Now, magnetic field. It is a region around the magnet within which its influence can be experienced. It is a region around the magnet within which its influence can be experienced. Means within that region, if you keep another magnet or magnetic substance, then that magnet or magnetic substance will experience a force, and this force is either attractive or repulsive in nature. So the region within which a magnet is active or it can influences another magnet or magnetic substance, and this region or area is called magnetic field of that magnet. And this magnetic field is denoted by B, and it has the magnitude and direction both, so it is a vector quantity. Now, SI unit of magnetic field is Tesla. SI unit of magnetic field is Tesla. You have to remember the name of the SI unit of magnetic field. It is Tesla. So this is all about the magnetic fields. Today is this much. In the next class we will deal about the magnetic lines of force and all. Till then, thank you.